Okay, so we have already talked about square root functions, but we are going to look at square root functions again, and then we're also going to look at cube root functions because we've been talking about radicals so far this chapter, and we want to make sure that we know what they look like graphically. We looked at square root functions, though, back in chapter 1, so we already know that the parent function for the square root is f of x equals the square root of x. We also have already talked about the parent function table. And when we talked about it in chapter 1, we talked about using x values that were convenient. So we're only going to use x values that are perfect squares. Since it's a square root function, we cannot have a negative x value because we can't take the square root of a negative and still get a real number. So we're going to focus on real numbers. So the first number that we can actually take the square root of is 0. Square root of 0 is 0. Then we have 1. Square root of 1 is 1. 4. Square root of 4 is 2. And then lastly, we're going to use just another one. And we'll do the square root of 9, which is 3. The parent function graph, again, we've seen this before, but we just plot those points. Oops. And it looks like that. Well, hang on, sorry. There we go. The domain of this. Remember, domain is from left to right. If we're going from the left, it starts at 0, and it touches 0, so we use a bracket because it's included. And it goes over forever to the right, which means that it goes to infinity. Since we can never touch infinity, we use a parenthesis. Range goes from bottom to top. Again, it starts at 0, can touch 0, and it goes up forever, so it goes to infinity. We can't touch infinity. We also have the cube root function. It's a cube root, so the parent is just f of x equals the cube root of x. Parent function table. We can take the cube root of a negative, so we're going to use some negatives as well here. We're going to start with negative 8, because negative 2, 0, nope, just kidding, lies. Negative 8, negative 1. I don't want to use negative 2 because it's not a perfect cube, but negative 1 is 0, 1, and 8. They're all perfect cubes, that's why I picked those numbers, and they're the 5 numbers that are all around 0, so that's why I picked them. The cube root of negative 8 is negative 2. The cube root of negative 1 is negative 1. Cube root of 0 is 0. Cube root of 1 is 1. Cube root of 8 is 2. Again, we'll graph them. So we've got negative 8. Oops, that's not right. Negative 8, negative 2. Negative 1, negative 1. 0, 0. 1, 1. And 8, 2. Connect them. Domain is going to be all real numbers, so negative infinity to infinity, because it goes forever in either direction. It also goes forever from bottom to top. So again, all real numbers or negative infinity to infinity. Just like before, we're going to talk about the transformations on them. This a value is still going to do a vertical stretch or shrink. It could also do a reflection. That h is going to shift left or right, and it's inside, so remember that the inside lies, and that k gives us a vertical shift up or down. example, we're going to describe it. So that negative gives us a reflection over the x-axis. And there's a box on your notes for, or there's a spot on your notes for describe. For some reason, I don't have one here. And then this plus 4 tells us that we're going up 4. Function table. We're going to start with the parent function table for the cube root. So negative 8, negative 1, 0, 1, 8, which is negative 2, negative 1, 0, 1, 2. Then we're going to put our transformations on our table. Remember that the outside affects the y, the inside affects the x. We want to go from left to right. So starting at the left, we have that negative first. So it's on the outside. It's going to affect the y. I'm just going to multiply by negative. So it becomes positive 2, positive 1, 0, negative 1, negative 2. And then we're going up 4, again on the outside. So on the y column, I'm going to add 4, which gives me 6. 5, 4, 3, 2. I graph them. Negative 8, positive 6, negative 1, positive 5, 0, 4, 1, 3. That's 2, 3. Again. 1, 3, and 8, 2. Connect. Domain didn't really change because it's all real numbers, so it's still, domain and range are still going to be all real numbers. They're not going to change on our cube root functions. Look at the next example. Very similar to the one that we did before, except that this one has a -1 on the inside. So, we'll start with our xy table. Negative 8, negative 1, 0, 1, 8. Negative 2, negative 1, 0, 1, 2. Starting from the left, we're going to multiply by a negative. Then, we're going to add 4, because that's also on the outside. So we get 6, 5, 4, 3, 2. And then this -1, that's on the inside, so it affects the x in the inside lie. So even though it says -1, I'm actually going to add 1. So negative 7, 0, 1, 2, 9. I'll graph them. Negative 7, 6, 0, 5, 1, 4, 2, 3, and 9, 2. And I'll connect them. So this one, here's the description. So it reflects over the x-axis. That -1 is going to make it go right 1. And that +4 makes it go up 4. Domain and range, again, not going to change. Still all real numbers. Last example. We have a square root function, so we're going to start with the square root function table. So 0, 1, 4, 9, 0, 1, 2, 3. We have this times a half. It goes on the y side. And I get 0, 1/2, 1. Oh, come on. Sorry. Zero, 1/2, 1, and 3/2. I have a -2 inside, which means that I will +2 on the x side, which gives me 2, 3, 5, 11. And then I have a -2 on the outside. So I'm going to go to the y and do a -2. So I get -2. Oh, I really don't want to do a half minus 2, so I'm actually going to skip that one. 1 minus 2 is -1. I'm going to skip the next one. And because I need another point that's actually kind of valid, I'm going to add in the next perfect square. So I'm going to put in 16, which means that y would be 4, times a half is 2, minus 2 is 0. That's a cleaner point for me, so I'm going to go ahead and use that. I'm going to add 2 to it. It says 18. That's going to be way off my graph, but that's okay. It gives me an idea of what this line is doing. So I go to graph it. Just change colors for grins. 2, -2, 3, -1, and this one, it goes all the way over to 18, 0. So that's going to be, I don't know, it's going to be pretty far off, somewhere over there. So my line here starts to go like this. Here's one thing you should notice, though. I'm going to go back. On the square root function, you're going to have a stop on one side and an arrow on the other. It may get, no, it's always going to be like that because we don't do reflections over the y-axis. So it's always going to stop on the left side and continue on to the right side. The cube root function will always continue on both sides. Okay? So, with this square root function, the domain, where our x values start, they start at +2, and you can touch it, and they continue forever. Our range begins at -2, and again continues forever. Our description, we have a vertical shrink by a half. We go right 2 because the inside lies, and then we go down 2. So that's it.